Math 1060, Trigonometry 1.3, the unit circle. So in section 1.2, after we talked about, well, yeah, before we did section 1.2, after section 1.1, when you started sketching angles, oriented angles in standard position on a graph, we started filling in this unit circle right here with all of the angles in degrees and radians. So we have other things to talk about on this circle, and that's what we're going to do today. So we already know where all of the angles are located. This would be good stuff to memorize, things that we will practice, or that would be good to practice, to drill yourself on where those are if you need to. Okay, so now let's learn about what that unit circle actually means. So a unit circle is a circle with a radius of 1 unit. So unit, circle, radius, 1 unit. The center's at 0, 0 on the coordinate plane. The equation for that unit circle is x squared plus y squared equals 1. Think back to Math 1050, to conic sections and circles. Center at 0, 0, radius 1. Does it make sense that that's our equation for this circle, right? But it should really remind you of Pythagorean theorem, except instead of r squared, or instead of a squared plus b squared equals c squared, it's just a 1. So we're just using that radius of 1, and that is going to be helpful when we start finding sines, cosines, and tangents. Okay, let's start by just practicing sketching again. So we already talked about what oriented angles are. So we're sketching an arc for each of these oriented angles. So the arc goes along the edge of the unit circle, is kind of what you're saying it's doing. So 3 pi fourths, let me kind of blow this up a little. So 3 pi fourths, go ahead and sketch that, where it goes. I know I didn't put the actual circles in here, so you'll just have to kind of estimate where you want your unit circle to be. Do you remember, can you just visualize in your head where 3 pi fourths would be? Because this is, you're supposed to just be starting to get familiar with these. So in case you've forgotten, 3 pi fourths would be 135 degrees. I didn't draw that very well, but here's the arc that would go to that terminal side of that angle. So I just sketched the oriented arc on what would be the unit circle. And the arrow is telling us what direction it's going. That's what the word oriented means. Okay, any questions on that one? You guys go ahead and try through these on your own if you want. I would pause for 3 and 4 because notice this note. Note that any angle not labeled as degrees is by default assumed to be in radians. So it's going to be easier to take those angles in radians and change them to degrees first so we can figure out where they're going to be on the circle because they don't have pi's on them. If it had a pi on it, we'd be able to find it easier, but they don't. So negative 2 pi. If your oriented arc goes all the way around the circle with the arrow pointing back to the x-axis, but that whole thing went negative, so clockwise, then that's correct. Questions on that one? Starting pretty simple here, right? Let's go ahead and change negative 2 radians to degrees. So I'm going to multiply by 180 over pi. So that would be negative 360 divided by pi. I'm going to go ahead and do an approximate answer. So negative 360 divide pi. So negative 114 degrees. 114.6 approximately. So that oriented angle or oriented arc on the unit circle would be not all the way to where negative 135 would be in the middle, but less than that. Past 90, not to 135, maybe about there. No need to use a protractor, just an estimate. I do need to make it oriented though by putting the little arrow. Okay, and then the last one, 21, so I'm going to multiply that by 180 over pi. Whew, and I got 1203.2 degrees. I don't know where that is, so I want to find its coterminal angle. So I'm going to start subtracting increments of 360. So 843 minus another 360 would take us down to 483. We're almost where we're going to be able to recognize this. Minus another 360. So that took us down to 123.2. So now that's an angle I can sketch. So starting at the positive x-axis, creating a unit circle around to approximately, not all the way to 235, or 135, sorry, but further than 90, and also further than the last one we just did, which was like 114, right? I don't know. My angles are not incredibly accurate because I don't even like this one. This one looks more like 135 than this one does. So I'm being a little critical of myself here. Maybe. Nah, that didn't help, did it? Those are just that part. Angle that a little more. That could be better. That doesn't quite look 135 anymore. This one didn't even look 135 to begin with. Anyway, you'll forgive me. You know what we're talking about, right? Perfect. Awesome. Okay, so just a reminder, we already went through where all of these angles are located in radians and degrees, so we saved ourselves that time on this circle, right? So now, to focus on the triangles we focused on in section 1.2, are special right triangles. So guess which special right triangle this one is.